at adding and subtracting polynomials today. Okay, we're eventually going to get into working with quadratic equations in this unit 5 that we're starting today. But we need to review these algebraic skills of adding and subtracting polynomials, and tomorrow we'll review multiplying polynomials. Okay, because here you can see in this first example, we've got two quadratic expressions. See how it's in the form of that x squared, ax squared plus bx plus c form, the trinomial. Okay, I believe there was a typo when the page was printed. So right here on this minus 7t in the top one, I think y'all's has an exponent there. You just need to mark it out. That was not supposed to be there. This is what it should look like. But when we are, we need to be sure we understand that when we're combining like terms have to have the same variable to the same power. So if they have a different exponent, they are not like terms and we cannot combine them. Okay, they have to have the same variable to the same power. Then we can combine them, and we combine them by adding their coefficients, the numbers multiplied in front of the variable. So here is a strategy when combining like terms is to stack vertically, stack your expressions vertically, and line up the like terms. So the t squareds are lined up, the t's are lined up, the constants are lined up. Okay, and so when we combine those, this is an understood 1 if there is no coefficient. So 1 and 7 is 8t squared. Negative 7 and negative 4 is negative 11t. And then the constants are negative 3 and positive 2, which is negative 1. Okay, so if you like to stack them vertically, to make it easier to combine your like terms, you can totally do that. Okay, not everybody does that, and that's okay. Some of y'all are fine seeing it written horizontally like this. Now, when you're subtracting instead of adding, we do have to be careful because you're subtracting this entire set of parentheses, this entire expression inside there. So the negative, the minus, has to be distributed to all terms inside there. Okay, so when that is rewritten, you can see the first expression was just copied down exactly as it was, but then this one, all of the signs changed because of that minus. So it became positive 3v squared minus 2v minus 7. And then those like terms are combined in each column. So far, so good? All right, so let's try it. Okay, so this first one, example A here, we have addition. Okay, so addition, we don't need to rewrite anything. Okay, we can essentially just drop the parentheses. So some of you would maybe prefer to write these stacked, and that's fine, you can do that, but you don't have to. There's different strategies. You can use highlighters and highlight like terms. So here's a 7x squared. Here's a negative x squared. Those are like terms because they have the same variable to the same power. They're both x squared. Okay, there are two x terms that will need to be combined, and there are two constants that will need to be combined. Okay, so you could do it by highlighting to see what is supposed to be combined. You can stack them. Okay, you can even just use underlining. If you don't have highlighters, that's fine. You could just use different types of highlighting or circling or boxing in. Okay, so I could just underline the 7x squared and the negative x squared. So those will combine to 6x squared. The negative 6x and positive 5x, that would combine to negative 1x, which you don't have to write the 1. And then the 3 and 2 would combine to a positive 5. So you can use whatever strategy you prefer, highlighting like terms, underlining with the same type of underlining for like terms, or you can stack them so that the like terms are on top of each other. Okay, with addition, I think I prefer just the underlining. Okay, so I'm going to do just the underlining here with B because this is another addition one. Or actually, I'll show you. You can do like circling or boxing in. If you can't think of other types of underlining to make them different, you could say, okay, this is an x squared. This is an x squared. Then you could say this is a x term. This is an x term. This is a constant. This is a constant. So you could box them in different shapes to match them up. So that could be the x squareds would combine to 6x squared. The 6x and 5x, both positive, would be 11x. And then that was a positive 3 minus 1, so that'd be plus 2. So you don't have to rewrite them, stacking them, unless you want to. Okay, I prefer less writing, so I don't tend to do that unless it's subtraction. If it is subtraction, like in C here, I am going to eventually, I'm going to rewrite this because I have to distribute the negative and it's going to change all these signs. Some of you may be able to just do that in your head, but I like to rewrite it. So since I'm rewriting it anyway, I may as well rewrite it stacked. So I'm going to write the first one. Now in this second one, I've distributed the negative. Now I need to make sure I'm lining up the correct like terms. So that would be negative 3x cubed. So I'm going to put that under the x cubed term here. That would become plus 4x squared. Put that under the x squared term. Now there is no x term, so this is there's going to be a space left, blank. But then that becomes a minus 6, but I'm going to line that up under the other constant. So notice I have that blank space because there was not a like term for this negative 2x. There was no x term here. So I just left a blank space. So then when I add these, I get 2x cubed plus 5x squared minus 2x minus 3. So for me, if it's a minus, I'll end up stacking them. Okay, I don't think that's a bad idea. Okay, but if it's addition, I usually just underline or circle and box in different shapes to match the like terms up. All right, sometimes it can be more complex. Here on the back, you've got 3 terms that we're combining. Okay, we've got the first one plus the second one minus the third one. Okay, so that minus has to be distributed to that last trinomial. So all of those signs are going to change. So you can stack all 3 together. Here's the first expression, and then the second expression. And then the third expression with that negative distributed would be positive 4y squared minus 5y minus 4. And then combine all at once. So for the y squareds, that's 6, 9, and 4. So that is 19y squared. For the y's, that's 6, 7, and negative 5. So that ends up being 8y, positive 8y. And then for the constants, you've got 6 minus 3 minus 4. So that ends up being minus 1. Okay, if you don't want to do it all at once here, you could add the first 2 and then subtract the next one. But I think doing it all at once is a little quicker. All right, now this one's an application problem. They give you a triangle and they tell you 2 of the side lengths as expressions, and they give you the perimeter, and they ask for the third side length. What does perimeter mean? They've given me the perimeter. How do you find the perimeter? What's like the formula, or what do you do to get a perimeter? Perimeter is adding up all the sides, right? So you've got a couple options here. You can break this down into multiple steps. Pretend these were numbers instead of expressions. If they told me these sides were 2 and 3 and the perimeter was 12, or that wouldn't work. If they told me the sides were 2 and 3 and the perimeter was like 8, I would add up the 2 that I know and subtract from the perimeter, right? That's what you did to get that. So I can do that here. I can add up the sides that I know, these two expressions, and then I can subtract that from the perimeter. Or if you want to do it all at once, you can take the perimeter. So I'm going to call the sides ABC, just to give you like a little equation. So I could do A plus C and then subtract that, not from 180, from the perimeter. And that would equal the third side. Okay, so that's what we just talked about. Or I could just take the perimeter, because the perimeter is all three sides added up. Okay, so if I'm looking for side B there, couldn't I just subtract the C and A to the other side to get side B alone? Wouldn't that work? Yes. Okay, so I can do it in 2 steps like this, or I can stack it all. I can start with the perimeter and subtract side A and subtract side C. Okay, so I can stack the perimeter on top. And then I am subtracting this side and subtracting this side. Okay, and actually let me do a different color. I'll color code this for us. Do this one in green. Okay, so if I subtract side A, that becomes negative 5x, and I'm going to line that up under the x term, minus 10. And then if I subtract side C here, that's going to become negative 4x squared, and then minus 7. See how I lined everything up with like terms? Okay, so this side A didn't have an x squared term. Okay, side C didn't have an x term. That's okay, I just left some blank space there. So now I'm going to go down and combine these. Okay, so 8x squared and negative 4x squared is 4x squared. 10x minus 5x is plus 5x. And 22 minus 10 is 12, minus 7, minus 5. So that's the third side. Okay, so I used this method. I did the perimeter minus the 2 sides that we know. If you wanted to combine the sides that you know first in one step and then do the subtraction, that's fine too. And you would only have 2 things in your stack. You'll feel good about that? All right, I think it's pretty straightforward. You're just combining like terms. Just be careful when it's subtraction that you distribute the negatives. Okay, you've got a practice in Delta Math. It is short and sweet. Looks like this. When you open up Delta Math, you should see 1031, adding and subtracting polynomials. And I'm just having you get 6 of them right. Okay, you may just have to do 6. Maybe you get one wrong, you got to do a couple extra. Okay, but it's a short and sweet assignment, but I want you to check also your past due tab. Anything here where it says late credit available, any of these assignments may still be showing. Okay, the most recent couple are at 75% credit still until this is Sunday. Okay, so through the weekend, you can still get 75% credit on those last 2 Delta maths. Everything else is at 50% credit till December 12th. Okay, so you can go back and get those individual daily grades up by completing more of those. If they're showing up here under late credit available, under the past due tab, that means you have not finished them. If you finished them, they would be under the complete tab. Okay, and then also just don't forget your review and aware. I'll be putting review grades in today. If you did not submit the review and aware, you're going to get a 0 put in. So make sure that you get that submitted if you have not already.